So in this video, we're going to be dealing with multiplying and dividing rational functions with exponents. So let's say that I had the function f of x, which is equal to x raised to the fifth power all over 2, which is also equivalent to 1/2 x to the fifth power. And let's say that I had g of x, which is equal to 2 over x to the fourth power. So what I wanted to find, so let's say that I wanted to find f of x times g of x. How would I do this? Well, f of x is just, so let me set this up. F of x times g of x, this is going to be equal to x to the fifth power over 2 times 2 over x to the fourth power. Whenever we deal with multiplication like this, what we like to do is we like to take the numerators and multiply them together, and then the denominators and multiply them together. So this is what we dealt with when we were doing pre-algebra and other sorts of math. When we have like 2 by 4 times 1/2, we just multiply these and this, which would be 2 by 8, which is 1/4. Now another way we could have done this, this problem and even this problem, is, and this would have been faster because we don't have to do the simplification at the end, is we could just notice that we can cancel these two here. Sometimes that could get confusing early on, but as you get used to it, it's really powerful to cancel first. Remember to cancel the ones, so you can cancel in two directions. You can cancel diagonally and you can cancel up or down. So you can cancel in this way. So think about it like an N, right? An N shape. You can cancel up or down like this. You can cancel diagonally, and you can cancel up or down in this one as well. But you cannot cancel, you cannot cancel like this. You can't if you wanted to cancel these two, like this is 2 and this is 1, you can't do that. That would be incorrect. You can't do that. All right, so this is just going to be cancel, so 2 and 2 cancel. This would just, now we can multiply this out, so this is what's 1/4, right? That was quite simple. This is the same logic over here, except we have variables and stuff. So what we would do is we would cancel these 2's, and here we can't really cancel anything, but when we rewrite it, you'll see that we can do something interesting. So this would just be equal to 5 minus 4, so x to the 5 minus 4, which is just simply equal to x. Now, let's say that I wanted to divide f of x and g of x. So let's say I wanted to do f of x over g of x. How would I do this one? Well, let me write this problem. So let me just write f of x here. So that's x to the fifth. Let me do this a little down. So x to the fifth over 2. And then all over, let me write like a big line, 2 over x to the fifth. X to the fourth, rather. So this is what we have here. Now, this is kind of interesting because it's kind of dividing two rational functions. It's kind of weird. But when we think about what we did before, when we just had numbers without variables, we had 2, let's say we had 2 over 4 divided by 1/2. How do we deal with this? Well, we dealt with this like this. We just made this 2 over 4 times the reciprocal. So the reciprocal of the denominator is just 2 over 1. So multiply by the reciprocal. So what we can do here is we can multiply these. Now, we can see that we can cancel this. This is 1, and this is 2. And then we can cancel up or down as well. This is just 1, and this is 1. So that's just equal to 1 times 1 over 1 times 1. That's just 1. So this is essentially, we just multiply by the reciprocal. We can do the same thing with functions that have x's and other variables. So this is just equal to x to the fifth power over 2 multiplied by the reciprocal. That's x to the fourth power over 2. Now, you might be tempted to cancel this. You might be tempted to say, oh, 2 and 2, we can cancel. But remember, it's only at an N shape that we can cancel. We cannot cancel like this, in this direction. So we cannot do that. This would just be equal to do that in blue. This would be equal to x to the fifth. Let me just write it out now. X to the fifth times x to the fourth all over 2 times 2, which is 4. Remember, x to the fifth times x to the fourth is x to the ninth, because 5 plus 4 is 9, over 4. This is what we end up with. All right, so that was just some simple examples of multiplying and dividing rational functions. There are many more examples that we can do. Let me do actually one more example. So one more example that we can work with here. All right. So let's say that I had g of x is equal to, let's do something interesting. Let's say that we had 2x to the negative fifth power over x to the 4/3 power, and then h of x was equal to, let's say we had x to the 9th power over 4x to the negative second power. So we have some rational exponents. We have some negative exponents. We have some other things. Let's just multiply and divide the two functions. So the question is, what is g of x times h of x? Right? That's the first question. And then the second question is, what is g of x divided by h of x? So how would we do this? Well, let me just set it up and then we can perform simplifications. What I would do actually is I would first rewrite this and simplify this, and then rewrite this and simplify this. And then I would do the multiplication and the division. So actually, let me do it that way. So this is g of x. So let me simplify g of x, and then let me simplify h of x. So let me do h of x in a different color, actually. Let's do that in green. So g of x can be simplified. We have this negative exponent, so we can take this and we can bring it down. And so that's just going to be equal to 2 over x to the 4/3 power times x to the 5th power. What is this equal to? So this is equal to 2 over x to the 4/3 times x to the 5th is just 4/3 plus 5. So 4 by 3 plus 5. We can multiply by 3, so this is just 15 by 3, which is 19 by 3. And we can't simplify this any further, so this is just x to the 19 by 3. Because 19 is a prime number, 3 is a prime number, we can't really do much here. So that's simplified. Let's do this one here. This is x to the 9th. We can bring the negative up, making it positive. So that becomes x to the 9th power times x squared all over 4, which is equal to x to the 11th power over 4. 9 plus 2 is 11. So now we have it kind of simplified in its entirely. So now we can solve these problems here. Let me do this one in blue. So what we would do is 2 over x to the 19 by 3 multiplied by x to the 11th by 4. Notice here that this becomes 1 and this becomes 2. So this just equals x to the 11th over 2x to the 19 by 3. So these are kind of weird numbers, but we can still work with them. So 11 minus 19 by 3, let me do this here. So 11 minus 19 by 3. You can do this by multiplying the denominator and the numerator by 3. So this is 33 by 3 minus 19 by 3. What is 33 minus 19? That's 14 by 3. Let me just double check. So 14 plus 19 is 29, 33. Yes, 33 by 3, 14 by 3. We can't simplify this any further, so that's just what we will stick with. So this is x to the 14 by 3, make that smaller, 14 by 3 divided by 2. And this is actually as simple as we can go. So we can't simplify this any further without really kind of writing it in a more messy way. I guess you can bring this down, make it negative, but again, we don't really like negatives, so this is good. All right, so the next one is this one. We'll do this one. Let's do this one in green. I'll do this down here. So g of x is 2 over x to the 19 by 3. So 2 over x to the 19 by 3. And then we have divided by h of x, which is x to 11 by 4. But what I'll do is I'll just multiply by the reciprocal. So that's 4 over x to the 11th power. So that was multiplying by the reciprocal. Multiply by reciprocal. So this would make it like this. Then we have 2 times 4, which is 8, over x to the 19 by 3 times x to the 11th. So this just becomes 19 by 3 plus 11. Here we did 19 by 3, or 11 minus 19 by 3. If we change this negative to a positive, what happens? So this is just positive. So this just becomes, so we just have the same thing, except we have 33 plus 19, which is 52 by 3. Let me double check. So 11 plus 19 by 3, so multiply 3, 33 by 3 plus 19 by 3. So 33 plus 20 is 53, right? 43, 53, minus 1, so that's 52. This division actually works out pretty well. This is 1 and 2. Well, it doesn't work out that well. We have a mixed fraction, so really it doesn't work out. So this is 52 by 3. We can't really simplify this any further than we have it here. So this is x to the 52 by 3. And for a second, I thought this would work out, but it doesn't work out, and it makes sense why it doesn't work out, because for 3, we have to, in order for a number to be divisible by 3, we have to have the top, when we take the sum of the digits, so 5 plus 2 is 7, this has to be divisible by 3, which isn't divisible. But if we had something like 12 plus 1 plus 2 is 3, right? 1 plus 2 is 3. 3 is divisible by 3, of course. And another number like 18, we'd have 18, which is 1 plus 8 is 9, which is also divisible by 3. Okay, so 52 by 3. This is about as much as we can do with this problem. We can't really simplify this further. We can bring it up and make it negative, but that doesn't really help us. Okay, so this has been quite a long video, but I hope you found this video helpful, and this is not very difficult to do once you get practice.